This is Unit 4, Lesson 3, the greatest common factor. The greatest common factor, or GCF, is just the largest number that divides exactly into two or more numbers, and that can include variables. For this lesson, we're just going to look at numbers. Now let's take, for example, the greatest common factor of 20 and 36. If we listed the factors of 20, they would be 1, 2, 4, 5, 10, and 20. Because 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. For 36, the factors would be 1, 2, 3, 4, 9, 12, 18, and 36. 1 times 36 is 36, 2 times 18 is 36, 3 times 12, and 4 times 9 are 36. Okay, so what factors do 20 and 36 have in common? Well, there's 1, there's 2, and there is 4. So the factors that 20 and 36 have in common are 1, 2, and 4. Therefore, the biggest one, or the greatest common factor, would be 4. Now you can kind of see how this could be really cumbersome if you're looking for a greatest common factor of really big numbers or more than just two numbers. So for that, we have a different process of finding the greatest common factor. And the process we'll use is, first we're going to list the prime factors of each number. We're going to do that with a factor tree. And then we're going to multiply the prime factors that our numbers have in common. Let's take a look at the greatest common factor of 126 and 144. If we did a factor tree for both of these, 126 and 144, 126 is 2 times 63, 63 is 7 times 9, 9 is 3 times 3. 144, we can go with 12 times 12, and for each of the 12s, those are 4 times 3, and the 4s can be 2 times 2. And if we list the prime factors of each number, 126 equals 2 times 3 times 3 times 7, and 144 equals 2 times 2 times 2 times 2 times 3 times 3. And then we can see that they have a 2 in common, a 3 in common, and another 3 in common. So then your greatest common factor is going to be 2 times 3 times 3, which is 18. Now this process can work for 3 numbers or 4 numbers as well. So let's take a look at an example with 3 numbers in it. Greatest common factor of 48, 12, and 56. So we start our process by finding the prime factors using a factor tree. So for 48, that's 4 times 12. 4 is 2 times 2. 12 is 4 times 3. 4 is 2 times 2. 12 is 4 times 3. And 4 is 2 times 2. 56 is 7 times 8. 8 is 4 times 2. 4 is 2 times 2. So when we list the prime factors of each, for 48, there are 1, 2, 3, 4 2s. So that's 2 to the power 4 multiplied by 3 there. For 12, 2 to the power of 2 multiplied by 3. And for 56, 2 to the power of 1, 2, 3. 2 to the power of 3 multiplied by 7. So when we look at what's in common, they all have 2s. They all have 2 2s, at least 2 2s. So the greatest common factor would be the 2 2s that each of them have, and that's it. The greatest common factor would be 4. Yes, 48 has a 3, and 12 has a 3, but 56 does not have a 3, so we can't use 3. The prime factors have to be common for each of the 3 numbers. Okay, so if you're comfortable with this process, you can go ahead and pause the video, try the next two examples, and then compare your answers with me. Okay, 15, 45, and 85, greatest common factor. We start with factor trees for each of those numbers to break them down into their prime factors. 15 is 3 times 5, 45 is 9 times 5, 9 is 3 times 3, 85 is 5 times 17. So let's list the prime factors of each. We have 15 equals 3 times 5, 45 equals 3 squared times 5, because there are 1, 2, 3's there, and 85 equals 5 times 17. And we can see that each of these numbers has 5 as a factor, so the greatest common factor equals 5. Next example, we have 3 numbers. We want to find the greatest common factor. We start with factor trees for all 3 numbers. 171 is 3 times 57, and 57 is 3 times 19. 285 is 5 times 57, 57 is 3 times 19, and 399 is 3 times 133, and 133 is 7 times 19. Listing the prime factors of each number, 171 is 3 squared times 19, 285 is 3 times 5 times 19, and 399 is 3 times 7 times 19. Comparing all the factors, each has 1 3 and each has 119, so the greatest common factor equals 3 times 19, which is 57. Now let's take a look at a word problem. Here we have a baker that has a rectangular dessert. We want to divide that rectangular dessert into equal square pieces. What's the side length of the largest possible square? Now remember, with squares, each side length is the same. So what we're really trying to do is divide 360 evenly using the same length as we would if we divided 250 evenly. So really what we're trying to do is find the greatest common factor of 360 and 250. So let's take a look at doing that. 360 and 250. 360 is 36 times 10. 36 is 6 times 6. Each of those 6's is 3 times 2. And the 10 is a 5 times 2. For 250, that could be 25 times 10. 25 is 5 times 5. 10 is 2 times 5. So if we list our factors, we can do it over here. 360 is 2 to the power of 1, 2, 3, multiplied by 3 to the power of 2, multiplied by 5. And 250 would be 5 to the power of 2. Sorry, that's 5 to the power of 3, multiplied by 2. So, comparing the factors, there is 1 5 in common, and there is 1 2 in common. So the greatest common factor would be 2 times 5, which is 10. And that's the end of this lesson.